Hi, welcome to the first lecture in Statistics for the Social Sciences. I am Jessica Bishop-Royse. I'm the lecturer. Before we get too far into the nitty-gritty of statistics, we're going to review first the research process. The research process is basically a cascade of events that occurs once a researcher develops a research question. Now, the research question comes about usually as a sort of at the intersection of an interest that a researcher has and the field that they're working in. Often it comes about when a researcher notices a sort of gap in knowledge, or just that there are questions that remain unanswered based on their sort of experience with the literature. And then so that kind of basically sets a course for the research process for that researcher. Once he or she has their research question in mind, the next step for them would be reviewing the literature, just to ensure that their question hasn't already been answered, and also to determine if it has been answered, what are the ways it's been answered. And sometimes the research question is driven by that. It's like, well, X researcher has come up with this solution or this answer. I disagree with his methods, or I disagree with that methodology, or I just disagree with their approach. And so basically the review of literature sort of informs continued efforts in answering this research question. Once that has been conducted, the researcher will then operationalize their research question. And basically this is a process of determining what sort of characteristics or factors that researcher believes will adequately represent a particular research question. So one way to think about this is conceptualizing education or socioeconomic status. If you're interested in knowing how much somebody makes per year, or more broadly, someone's social class, one thing you might ask them is their education, and with the idea being that people who have more education are going to make more money. Obviously, this doesn't always hold true, but this kind of rests on a set of assumptions that we have about the relationship between education and class in the United States. After the operationalization has happened, the researcher would then move on to data collection, and this helps. Basically, the researcher needs to keep in mind, the questions that he's asking and how he's asking them when it comes to data collection. Because how you ask a question, what questions you ask, it basically will determine how you ask them. For example, collecting data in an anonymous web-based survey is a little different than collecting data in a face-to-face interview. Each are fraught with their own, difficulties and advantages. But for the most part, you want to choose the method of data collection that is going to get you the best and most reliable data, so that you can move on to analysis. Analysis is basically the scope of this class. We will attempt to take large amounts of data and interpret them and summarize them and present them so that it's meaningful information to anybody who reads it. And that is what we are doing here. All right. So, social research, why? Big questions. Mostly because we're interested in the quote-unquote objective exploration of nature of social reality, causes of states and behaviors. If we're thinking about this in specific terms, we're thinking about cause and effect, essentially. All right. However, I'd like to caution you on thinking about cause and effect in social sciences, mostly because we don't do hard science here. We don't do experimental studies, so we can't say definitively that something causes something else. So in social sciences, we think about relationships. We think about how an independent variable is related to a dependent variable, how increases in an independent variable are related to increases or decreases in the dependent variable. And that way we stay true to our sort of methodology, but also in our ability to interpret and generalize to larger populations and samples. All right, so one of the things that is a little different about this class that you might not have already picked up on is that I like to use examples from pop culture. I'm a huge fan of TV in general, and so I will try to frame examples around TV shows that you may or may not be familiar with, and I think it helps make the material a little bit more interesting and a little bit more engages students more. And so I offer you examples of zombies, walkers, biters, lame brains, whatever you want to call them. They are here for our review. If we were to pretend briefly that we had it on good authority that there will be a zombie outbreak in the next 5 years, and that it's not really a question about whether this is going to happen, but rather what kind of zombies they will be. And let's pretend for a second that you want to know what kind of zombies they will be so that you can adequately prepare for the zombie outbreak. Assuming that your methods of preparation will vary based on the type of zombie it's likely to be. Now we see this a lot in policy. We are often interested in sort of describing or learning about populations or social problems so that we could prescribe remedies, so we can do something about them. So in our particular case here, we want to know what kind of zombie it will be in the outbreak so that we can prepare adequately for that type of zombie. So I have presented here 3 types of zombies. There's the zombie from The Walking Dead, the ones from Zombieland, and the ones from the film version of World War Z. As you can see, while there are similarities across types of zombies, there are differences. For example, the Walking Dead zombies tend to be slow and have minimal climbing ability, as opposed to Zombieland zombies, which tend to move faster but also have competent climbing abilities. Compare those both to World War Z zombies, which is incredibly fast with superhuman climbing ability. Now, all 3 types of zombies can hear gunshots, but there is some sort of discussion about the level of intelligence that these things have. So the reason why you might be interested in this is if you were going to do preparation activities for the Walking Dead walkers, we're talking about doomsday prep, obviously, because you don't want to, get bitten going to the store for milk, but also physical training as in strength. These walkers can be killed with headshots, and as we see in the show, it's more efficient and safer if these things are killed without using a gun. Okay, and compare those types of preparation activities to what you might have for Zombieland, which is obviously doomsday prep, clearly, but also you might want to focus more of your physical training on cardio activities, so being able to outrun a zombie, or 2 or 3. Compare both of those to the zombies represented in the film version of World War Z, which is that there is no outrunning those zombies. There's no outclimbing those zombies. The best sort of method of preparation for those zombies is to just not be where they are. So your preparation priorities might be, instead of focusing on physical training, you might, if you wanted to survive that zombie outbreak, you might want to consider getting a second job so that you can afford to relocate to Alaska or Antarctica, or someplace where there aren't likely to be those zombies, or your own island out in the middle of the ocean. So this is kind of just a cheeky example of why we are interested in social research. We want to quantify and categorize groups and their sort of risks of being exposed to something, their risk of becoming something, their risk of not doing something, and we do this by looking at social categories. So often we'll look at males versus females, education, higher educated people versus less educated people, income, higher income people versus low income people, etc. All right, so this gets us to observations and variables. Now, variables are going to be any property or quantity that is recorded for each case. In our particular example, we think about variables being in a spreadsheet, for example. The variables are the things that, the columns basically. We want to record this quality for every single case, and that might be running speed, climbing ability, intelligence. If you're talking about survivors, you might include marital status or previous occupation, something that you would expect all the observations to have a measure for. Hold on a second. Essentially, we have two main types of variables. We have qualitative and quantitative. Qualitative are basically variables that are having to do with a category or sort of a nominal, measure of something. These tend to be like choice of weapon, location. The thing that's helpful for me to remember about the difference between qualitative and quantitative is qualitative tends to be something where ordering them doesn't make any sense. So if we were going to talk about choice of weapon, for example, and that was a variable in our data set, we had crossbows, axes, knives, screwdrivers, guns. In and of themselves, those qualities don't order well. So how can we put crossbows and axes above a gun or a katana? We can't. Based on no other information, there's no sensible way of ordering those. All right, so that's what qualitative variables are. Quantitative variables are those that arise from specific counts or measurements, basically numerical data. Okay, these are sometimes called interval variables, and they're essentially things that you would measure. So a running speed, intelligence, weight. You might also have number of walker kills. You might have number of survivors killed because you're an idiot, etc. Those are the types of things that you might see as a quantitative variable. Now, what I've done here is I've split up variables into the quantitative and the qualitative / categorical variables into two different types. Quantitative variables, you have two different types of measurement. You have a continuous interval measure and a discrete interval measure. A continuous interval measure is basically something that you could measure with a measuring tool like a watch or a clock or a measuring stick. And if you had the ability to do it, you could measure it at an infinite level of precision. Okay, so for example, you see this a lot if you think about things in time. Okay, so a 400-meter sprint time, you could measure that in minutes, seconds, tenths of a second, thousandths of a second, hundredths of a second, ten thousandths of a second, etc. You can take that down to a very, very, very precise level. Okay, compare that to a discrete interval variable, which is, it tends to be whole numbers of things. Okay, so you can't have 1.5 useless people in your group, or you couldn't have 1.5 zombie attacks a week. You basically have one zombie attack per week, or you have two. There's no middle ground there. Okay. Now, when you look into categorical variables or qualitative variables, you do have sort of nominal or unordered categories. For example, sex, male or female, alive or dead, type of zombie. Those who were bitten or versus those who died and then turned. And then you have ordinal or variables that have an ordered category scheme. So like better, same, worse, disagree, neutral, agree, small, medium, large. So that in and of themselves, they represent a location compared to the other categories, if that makes any sense. There is a special case variable that is, it's called a dummy variable. Basically, it's a binary situation where something is or it isn't. It's 1 or it's 0. All right. Essentially, we would look at these types of variables being something like female, 1, 0, either where females are 1 and males are 0. Zombies 1, 0, uselessness 1, 0, physically handicapped 1, 0, where whatever that variable is 1 and all others are 0. Keeping in mind that when we conceptualize these variables, we want them to be what they are or not. So you would not want to have something like sex here, okay, or living status, okay. Sex here would say, if you had a score of 1 or a score of 0, it doesn't tell you what the 1 is. Is the 1 male or female? Living status, 1, 0, is the 1 being a walker or is it being alive? So it's best to break it down even further and just provide the binary sort of categorization here. This will get a lot more useful when we get to regression analysis towards the end of the semester. It's possible to set up models to compare blacks versus whites, men versus women, etc. And when you do regression analysis, this becomes very elegant and very nice. All right, so observations. These are the individual units being measured in a data set. They could be individuals, like people. They could also be groups of people, as in survivor camps or groups. They could also be, zombies. They could be pens in a drawer. They could be a variety of things. But essentially, you're looking for observations to be the rows in a spreadsheet. The variables are the columns. Observations are the rows. All right, so a hypothesis in social science is basically it's a simple statement about the relationship between two variables. In very broad, high-level terms, we want to think about this in terms of one causing the other, okay? But keeping in mind, and Michonne is here to remind you of this, that in sociology and statistics, we don't really talk about something causing something else. Because we don't do hard sciences, we don't do lab science, we can't run 100 experiments on these cells reacting to this chemical. We can't do that. So conceptually, you want to think about the sort of relationship between variables being one causing the other, but you don't say that, just so we're clear. All right. As in terms of hypothesis language, we'll say that variable A, increases in variable A are related to decreases in variable B, and other such language like that. Okay, so one thing that we might do is we might look, if we're looking for bias in survivors, we might want to do a similar exercise. Here I have 5 characters that appear in seasons 1, 2, and 3 of The Walking Dead. I have given them completely arbitrary, completely subjective bigot scores, and I've looked around on the internet. Yes, I've actually spent time looking around on the internet for occupation of fictional characters in a television show. I am not ashamed to admit that. So one thing that you might, with the bigot score, basically I assign these a score of 1 to 10, 1 being the lowest and 10 being the highest. So one thing that we as social scientists and statisticians might be interested in is why are some characters in The Walking Dead so bigoted? Why are they such jerks? Okay. And so what you might do is you might kind of lay out all the variables that you have, or all the variables of interest, or all the things that you think might be related into a spreadsheet, something similar like this. Okay. Here we have people, the people with the lowest bigot scores are T-Dog and Glenn, and next lowest is Rick, followed by Daryl and Merle. Okay. So you might say, well, let's look at these two people, these two characters that had the highest bigot scores. What might they have in common with not only each other, but with the rest of the group? Okay, well, they are both relatively lowly educated. In fact, they have the 2 lowest levels of education among these 5. They're also white, but being white doesn't necessarily mean anything, because Rick down here is white and he has a relatively low score. Okay, so that doesn't make any sense. They are from Georgia. Maybe they're being bigots has something to do with the fact that they're from Georgia. Well, Rick is also from Georgia, so maybe that's not the best explanation. Okay, so looking at the most bigoted people is kind of weird. We're not able to say anything definitively. So let's look at the other end of the spectrum, people with the lowest bigot scores. We have Glenn and T-Dog. Glenn and T-Dog are both minorities. T-Dog's black, Glenn's Asian. They also have two of the highest levels of education, okay, 18 years and 16 years. And they're both from the north. Maybe this is a northern thing versus a southern thing, okay? So basically, this is what social science is that we are constantly looking for the relationships between a variable of interest and other variables that might explain that variable of interest. All right, survey research essentially is retrospective in nature. We don't subject any particular group to a manipulation. We don't say we're going to give all these people drugs and we're going to give all these other people, healthy food. We're not going to do that in surveys. We don't have any way to sort of stipulate independent variables, although we do get a lot more of independent variables with survey research, simply because it's cheap. Once you get somebody to sit down for a survey and answer it, you can ask them a lot of questions, which gets us a lot more information, a lot more variables. One thing to keep in mind, though, with survey research is that depending on your sample, you might have questions or obstacles to representativeness. If you conduct a survey, a web-based online survey, anonymous, if you do that, okay, you might not be able to sort of take that data and speak about its representativeness to the whole population, because there are certain systematic biases in that sample. There are people who don't have as much access to the internet, who may have lower levels of socioeconomic status or education or comfortableness working with questions and interacting on the web. So that's one thing to keep in mind when you're doing survey research. There's also other types of research. There's experiments, where there's observational study designed experiments. These are anything from people conducting sort of hypotheticals and scenarios to research that it would never be allowed to pass an institutional review, an IRB review. That would never happen. Experimental units tend to be divided into two groups. There's research groups and control groups, where the research group will get this certain level of conditions. They'll be the ones that are subject to whatever bad thing it is that you're doing a research on, versus a control group that doesn't get that. In experiments, you have a response variable. It's the dependent variable. It's the variable that we expect to change based on whatever conditions we subject it to. Factors are the independent variables. These are the things that we conceptualize will explain changes in the response variables, if that makes sense. Independent variables, we tend to think of them as predictors, characteristics of interest, etc. We would look for change. We would explain the dependent variable, the response variable, by saying increases in the independent variable or decreases in the independent variable precede changes in the dependent variable. That's how we conceptualize independent and dependent variables. There's other types of research out there. There's content analysis, which is basically when you do analysis of the content of an organization's materials. You could do this with, for example, an advocacy group. You could do a content analysis of all of their blog posts and web pages, etc. A participant observation study is where the researcher goes and interacts and participates in social behavior that he or she is assessing. And then a primary or secondary analysis is when you collect data for a particular project and then reuse the data and reconceptualize the data and use it to answer another question. Statistics. What is statistics? Statistics are facts of data of a numerical kind that are assembled, classified, tabulated to present significant information about a given topic. Essentially, there's two types of statistics. There's descriptive and inferential. Descriptive statistics tend to be quote-unquote objective measures, and inferential statistics tend to be what we use to generalize from a sample to a population, or prediction. Often we use this for decision making. And so, with inferential statistics, we might say something like, for every year increase of education, we would expect to see a 0.05% reduction in the risk of a woman giving birth to a low birth weight baby. That's the type of inferential analysis we're getting at with this. All right, so we have an exercise here. I've given you 2, 4, 6, 8 variables, and I would like you to declare whether or not they are nominal, ordinal, or interval. The next slide actually has the answers in red. So what I would suggest is potentially hitting pause, writing out your answers, and then when you're done, replay, or hit pause again, and turn it back on, and then you'll have the answers. If that makes any sense. All right, so moving on to the next part. Actually, I guess I should go back to this and talk about the answers. Keeping in mind that any variable that has, that the main quality that you get from it is just the name, like gender, or neighborhood residence, like, as in Bucktown, Lincoln Park, etc. Those are going to be nominal variables, all right? Any variable that has a sort of measurement component, as in number of years of age, number of years of education, annual income, those are going to be interval level variables. And then if it's a categorization where there is some order to it, as in some high school, some college degree, etc., or social class, as in upper, middle, or lower, you're looking at an ordinal level variable. All right, so moving on to distributions. Distributions. They must be in a form where you can measure and analyze them. You can look at them and sort of summarize distributions with graphical methods or with numerical methods. Distributions of a variable tell us what values the variable has and how often these values are present. All right, so when we look at categorical data or nominal data or ordinal data, basically groups of data, we have two main ways to look at them. You can the categorical data can be represented as frequencies, which are counts for numbers of each category. So in our zombie example, we might have counts of zombies and counts of survivors. Okay, so there are 14 zombies in this particular neighborhood and only 2 survivors. And then if you do that, you can pull it up to a higher level and go to proportions and percentages, which are basically the relative size of those categories. All right. Now, as you can see here, P proportions are denoted by basically you put the frequency over the total number, because knowing the frequency is interesting and all that, but unless you know how it is related to the larger number or the larger group, it's not very helpful information. So say you are in a particular situation, you're in a store and you kill 1 zombie and you're like, wow, that's great, but you don't necessarily have a sense of how great that is without knowing how many other zombies there are. So if you kill 1 zombie and there was only 1 zombie, you have killed 100% of the zombies that were in that store with you. However, if you killed 1 zombie and there's 90 others, it's not really that great, because you still have another 89 to kill. There's still a whole bunch of zombies that are still walking around menacing your survivor group. So understanding proportions and percentages is important, so that we can have a sense of what the larger sort of representation is here. And as you can see, remember, proportions are the frequency divided by the total n, and to get percentages, you just times that by 100. So whatever the proportion is, times it by 100, and then you get a percent. All right, so another thing that you could do is you could, in categorical data, you can find ratios between two categories. So you can put the frequency of one, say number of zombies killed, over another one, which is number of zombies still alive. All right, so you could say what the ratio is of zombies that you've killed to zombies that you have not killed. You could do this with anything. You could do this with zombies, zombies and survivors. You would come up with a ratio that there are, 5 million zombies left in the United States and only 5,000 survivors. That would get you a ratio. You just put 5 million zombies over 5,000 survivors, and then you would come up with a ratio, and that ratio would be zombies to survivors in this particular time frame. All right, so sometimes we encounter data in a table as such, and it's often, like in the category, for example, like with our class, if we were to do a distribution of all the grades that you guys expect to get in this class, and so you have A, B, C, D, E, or A, B, C, D, F, and then you do the percentages like so, and then this is what you end up with. Please resist the urge to reorder the categories based on numerical percentage. For some reason, people like to do this. I don't know why, but Daryl Dixon here wants to remind you that life with biters is hard enough. You don't need to make it harder by doing this. So do not do this. All right, so we have here a bar graph of nominal data, and it's nominal data because we're looking at different types of weapons which have no, sort of relative meaning with each other. All right, so we don't say that an axe is better than a crossbow, is better than a shotgun, it's better than a pistol. It's just what they are. Okay, now something to keep in mind when you're looking and dealing with graphs is a few little things that you want to keep in mind. One, you want the graph to show the data. You want this figure to induce the reader to think about how the data are presented, and you want it to be sort of sensible. Like you want them looking at the numbers. You don't want them looking at the colors. You want to avoid distorting the data. So sometimes it happens by changing the scale over here, the axes. You don't do that. You want to try to do this with as little ink on the page as possible, because the more ink there is, the more complicated the graph is, and the more likely it is that people aren't going to understand it. We want the graph to encourage the reader to compare different pieces of that data. We want to, with a graph, make a very large data set coherent and really easy to understand. And we also want to reveal the underlying message of the data. If you do that with a graph, do all those things, then your graph is pretty amazing. All right, so with a pie chart, keep in mind that the pie represents all of something. So these would be all of the survivors. This pie chart represents 100% of the survivors, and each of these categories is a slice of the pie. All right. Now, this is contingent on all of these categories being mutually exclusive. So while, if you know anything about The Walking Dead, you would know that Carl, one, can never stay in the house, and so therefore is useless. But he's also, according, in as much as season 3 is showed us, bordering on being a psychopath. So at this point, we might need to add another category like useless child and psychopath. But until that happens, we just assume that all of these categories are mutually exclusive. So somebody can't be walker bait and a useless adult. Or they can't be a useful contributor and a useless child, etc. All right, so graphing the quantitative data. Oh, sorry, a little out of control here. All right. This is a governor, and let's suppose that we were interested in knowing how many bullets he fires at innocent civilians when he goes on a shooting rampage. This has happened before, and essentially this number could be anywhere from 0 to hundreds. All right. Before Milton died, he kept a record of how many bullets the governor fired at innocent survivors, civilians, when he did fire bullets at people. In the last 120 occasions, the governor has fired between 51 and 93 bullets at civilians, as you can see represented here in this table. Now, this is a lovely table, and it's interesting and everything, but you're sort of left with a, okay, so what sort of attitude towards it. I see that he has, fired 71 bullets at least 3 times. He has fired 80 bullets at least 4 times. Okay, so for usefulness, this table does not really cut it for us. So what we might do is we might do this table up a little bit. We might do some statistics to it. Okay. We would do that by dividing the measurements into class intervals. We might compute frequencies for each class interval. And we could also calculate proportions or percentages instead of frequencies, which are much more useful than frequencies. And so if we were going to do all of this, this is what we might do. We need to make the classes mutually exclusive and make sure that there's between 5 and 20. Depending on the type of data that you're looking at, you might have more or less classes. Okay. If you're looking at income in the United States, 20 classes might make sense. If you're looking at types of sodas that people like to drink, 5 might be enough. Okay, it kind of requires your best sense of the situation. We're also going to want to determine the range, which is the difference between the minimum and the maximum values. We're also going to want to determine the class width, which is the range divided by the number of classes, and then figure out what the upper and lower limit is for each class, and the midpoint, which is the highest score and the lowest score divided by 2. So this is what we've done here. Okay, you're welcome. This is nice and fun and games and everything, but we basically have come up with 15 classes, and the class is 3 wide. So 3 being 93, 94, 95, 90, 91, 92. Okay. We've determined that the midpoint is 72.5, which is smack dab in the middle, right about here, and that the range is 44. So if you were so inclined, you could go back to the table and confirm that the easy way to confirm is that there are 0 instances where 54, 55, or 56 bullets were fired, as well as 0 instances where 84, 85, and 86 bullets were fired, etc. You get my point. Okay? The relative frequency here is basically you take this number and divide it by this number. Okay? So you got it here. And then the cumulative frequency here is basically just adding this number to the number, adding this number to the number above it. All right? So you can get sort of a running total of how many there are. Now, if we were really clever, we would do a cumulative frequency proportion, which would basically get us all of these. And then that way we could say, oh yeah, 0.025% of the cases or the observations are above this point. And then, 90, whatever it is, 97, whatever 1.0 minus this is, are below. And it's nice and elegant and beautiful. All right, so one thing to keep in mind is that you can make a histogram for this information. And basically, if you took that table of the governor's shooting rampage bullet fired situation, you could make a table or make a figure showing how many instances 51, 52, or 53 bullets were fired. As we know, there's 0 here and 0, 0, 0. And basically all this is that this is the categorization and this is the frequency. Okay, so we know that on 15 occasions, 69, 70, or 71 bullets were fired by the governor. On 20 occasions, that number, there were 20 occasions where 66, 67, 68 bullets were fired, if that makes sense. Okay, so moving on. Cumulative frequencies have a total of value of 1.0, and they should have the same shape as a frequency histogram. what's really elegant about cumulative frequencies is that they can be converted to regular frequencies if you know the sample size. All right. So if you have the proportions and if you know the sample size, I think you can divide the sample size by the proportion to get the n. I think that's how you do that. Cumulative frequencies also tell you how many cases are above or below certain classes, which can be useful. All right, so moving on to distribution. Sometimes we care to display distributions as polygons, which are basically line graphs. And their shape tells us a lot about a variable. Symmetrical distributions have the mean as the very center here, and it has equal number of observations below the mean as it does above the mean. And then for cases with a positive skew, these are distributions where there are more observations above the mean than below. And then for the negative skew polygons, it's the opposite, that there are, in this situation, more observations below the mean than there are above. Another sort of characteristic that we can look at with polygons is kurtosis, which is sometimes called a measure of the volatility of volatility, which is hilarious. There are three main types of kurtosis. There's the normal or mesokurtic curve, which is the green one here. Okay. The polygons that have scores of less than 3.0 are called platykurtic. I think it gets its name from the duck-billed platypus. Okay, not really, but it has that sort of platy, I think that's where that comes from, shape. Wider at the top, like so. All right. And then there's leptokurtic, which has a taller, skinnier top. And those are distributions that have kurtosis scores of greater than 3.0. And then the platykurtic are those with less than 3.0. And essentially, this is just a measure of the degree to which the distribution is centralized around a single mean. So, like, how clumped are they around? How clumped are the observations around a mean? Okay, so another type of polygon that we could look at are just line graphs, which is if we were to take if we were able to go back to the histogram and find the midpoint of each of those classes and mark it with a dot and then connect the dots, that's what you're looking at. It's very simple, very basic. All right, so one thing that you will see is that there are histograms and bar charts. Histograms are where all of the bars touch, and that is that's based on a theoretical reason. 0 to 10 should be right up next to 11 to 20, and 11 to 20 should be right up next to 21 to 30. Whereas with bar charts, you don't have an axe isn't so much an axe that it becomes a crossbow, and a crossbow isn't so much a crossbow that becomes a gun. This is a theoretical reason for keeping these apart. And so when you see these in tests and quizzes and other papers and stuff, know that if you're looking at a histogram, it's most likely quantitative data, and a qualitative data set is illustrated in a bar graph. All right, so moving on, we have 3 attributes of a distribution. We have central tendency, we have variability, and we have shape. All right, central tendency is like, where is a distribution centered? Variability is how much spread is there across the scores, and shape is how can you describe the overall shape of the distribution. Okay, measures of central tendency, we tend to get those with mean, median, and mode. All right, means are averages. Basically, you add up all the scores and divide by n. is symbolized by x with a bar over the top of it, or mu. And you usually only use those for interval level variables. All right. Median is basically the middle score. So you sort all the data and then you find the very middle. If that makes sense. And then you have mode, which is the most frequent score. So in order to understand the problems with of using only the mean as a central as a measure of central tendency, here is a brief example. I'm not going to confuse you by tripping all over myself trying to read that to you. So I think now is a good time to hit pause while you look at what happens when you exclude certain observations from a distribution and what it does to the mean. So hit pause. All right, moving on. So mean is a nice balance point. It takes into account all the values in a distribution, and it's usually like really easy to calculate, which is nice. And then one thing that some people will do with a deviation is they'll take the with a mean is they'll calculate a deviation. So instead of it just being a mean, they will take any given observation and see how far away it is from the mean. Okay, so just having a mean can be problematic because it doesn't necessarily account for all the observations, and it gives too much weight to some observations. So you can get around that by looking at the deviation, okay, which is basically just the distance from the mean. And then another thing that some will do is to sum up those deviations, and you'll get the sum of deviations. So every time you basically calculate a deviation for every observation in your data set and then add those up. All right. This can sometimes be problematic. So what some people have done is they square that value. They square the deviations, and this is sum of squares. I'm sorry, I didn't explain that right. Sometimes they will sum the deviations, like here, and that's denoted with the epsilon. It's a sigma. This guy right here, it's epsilon. All right. And then, so the next sort of step is a sum of squares. This minimizes, the mean minimizes the sum of squares. All right, and it's elegant, it's nice, it's mathematically well behaved. However, it's susceptible to outliers, as you saw with the Grant Hill example. And it's only for interval level variables. So if you have a categorical variable, this could be somewhat problematic. So one way to deal with the bias that happens with very influential observations is to use a weighted mean. And this is basically where you calculate the mean for each group, all right? And then you times it by the number of observations there are in that group, okay? So here you would get the mean for group 1 and then times it by the number of observations there were in group 1. And then you would add that figure to the same for 2 and the same for 3. And then you would divide that number by the total. And that is a way to allow all that doing a weighted mean allows all observations to contribute proportionally to the mean. All right, so another sort of way of finding a measure of central tendency is to look at the median, which is the exact middle of a distribution. The effect on outliers is somewhat minimalized because it's rare that you have a case where there's one outlier on one end of the distribution, not one on the other. So it's possible to sort of negate the outliers. Some would say it's not terribly useful for skewed observations where there's a few very strong observations at one end of the spectrum and then a whole bunch of observations at the other end. It usually doesn't take all the information into account. It basically just relies on the fact that there's 50% of the observation above and 50% of the observation below a certain level. It's not well behaved mathematically. It's kind of a pain in the ass to calculate. If you don't have the ability to sort your data, it will be difficult to find this. But it is useful for ordinal and interval level variables. Modes are, people like modes because they are because it assesses the most frequently occurring score. The mode sort of gives people a good sense of what is most of this data like. What are most of the incomes in the United States like? What are most of the education levels of people who go to whose kids go to Harvard, etc. There are, but some people say that it doesn't always exist. So you might not be really getting what you think you're getting, especially if your data is grouped in some type of scheme. I'm thinking of income. So very rare do we have, is it that people have the exact same income down to the very cent? And so one way researchers get around that is they'll drop the cents off of a measure. So instead of looking at people's income, seeing, oh, you made $89,791.21, they will drop off the 21 cents. And then if they don't end up with a mode that way, they might drop off the single dollars. They might just round up to tens or down to tens or whatever, or down to 20s, etc. So it gets a little bit slippery when you're talking about the mode and what you're actually, sort of showing with it. It ignores a lot of information and it's not necessarily central. If you have data that's sort of clustered around a certain part of the distribution, you're basically going to be ignoring the rest of the distribution. But the upside is that you can use it with nominal, ordinal, or interval level variables, which sometimes you have in the real world. All right, so that is the end of Lecture 1. Please, please, please bring your questions to class. Bring your insight, bring your questions, and I will try to provide more clarification should you need it. Thanks a bunch.